11th week of digital distance learning. This week we are going to talk about perimeter and area beyond the rectangles and triangles which we did last week. Remember, squares are a special type of rectangle, so rectangles and triangles from the previous video, and we are going to move on to parallelograms, trapezoids, and circles this week. If you have any questions, feel free to reach out to me or come to office hours. You can also sign up for an individual meeting. And remember that you need a piece of paper and a pencil so you can take notes during this video and take a picture of them at the end to submit it in Google Classroom to get all your points. You also need this blue piece of paper. If you do not have it, I have left a digital copy right here on the link to this video so you can have access to it as well. Just like last week, we are going to have a basic and an expert level so you can choose which level is appropriate for you. If you are watching one video, you feel like it is too difficult or too easy, you are always welcome to switch to another level, and we will actually get to practice. Since last week we had the benchmark, since last week we had the benchmark, we didn't get to do as much work as I was hoping we would, but don't worry, we get to make up for it this week. Talk to you soon. In this first example, we are going to talk about the area in the perimeter of the shaded region. A shaded region means an area that is blacked out, such as this part of the rectangle. Since we have a rectangle, I am going to use the formula for area. Area equals length times width, where my length is 5 and my width is 6. And remember, you can say 6 times 5 as well. It does not really matter which one is your length and which one is your width. 5 times 6 is 30 units squared, or 30 squared units rather. Now, we have found the entire rectangle. The problem is we only want the shaded region. Because of that, I need to divide by 2 because my region is half of the full rectangle. 30 divided by 2 is 15, and therefore the area is 15 square units. We could also have used the area for a triangle. Area is 1/2 base times height. The base is 6 and the height is 5. We would have had the same answer. Every triangle is half of a rectangle. That is why that formula works. In fact, if you take this triangle, base times height, and multiply it by 2, creating 2 triangles together, one on top of the other, you can then create a 90-degree angle within one of the triangles, which is required for a rectangle. You need 4 right angles. If you move that cutout section to the right side, then you can see a full rectangle. Every single triangle is half of a rectangle. That is why they have the same formula, but the triangle must be divided by 2. To find the perimeter, I have to now look at the shaded region and add all the sides. I have 5 plus 6 plus 1 missing side. Because it is a right triangle, I can use the Pythagorean theorem. A squared plus B squared equals C squared. Remember, A and B are interchangeable. You can say A is 6 or A is 5, but C must be away from the right angle. 6 squared plus 5 squared equals C squared. 6 squared is 36, 5 squared is 25, and we bring down the C squared. 36 plus 25 is 61. When we take the square root of 61, I'm actually going to put it into my calculator and get 7.8. Knowing the value of my hypotenuse, I can finally find the perimeter. My perimeter is going to be 7.8 plus each of the legs, 6 and 5. 7.8 plus 6 plus 5 is equal to 18.8 units. That was a lot of work. In this example, we have a parallelogram with parallel opposite sides, congruent opposite angles, a base of 6, and a height of 3. In order to find the area, I find the formula for my parallelogram to be base times height, which in this case is 6 times 3. 6 times 3 is 18 square units. So my area is 18 square units. In order to find the perimeter, I must find all the sides. The opposite sides of a parallelogram are always congruent. So we know we have our perimeter 6 plus 4 plus 6 plus 4, which is 20 units. What's a trapezoid? A trapezoid is a figure with exactly one set of parallel sides. This one also has a right angle. It doesn't have to. Here's another example of a trapezoid. It has exactly one set of parallel sides. Again, the top and the bottom here, but we also see a set of congruent sides. This is called an isosceles trapezoid. What about a trapezium? Here's a trapezium. It looks like a trapezoid, but it does not have parallel sides. This is a trapezium. This is a trapezoid. And it is a good thing we are talking about trapezoids because that is exactly the area formula we need for this example. Area is equal to 1/2 the height of base 1 plus base 2. The height being 6, forming that 90-degree angle with the ground, and the bases being 8 and 4 or 4 and 8. They are interchangeable. Now let's plug in those values where h is 6 and b1 and b2 are 4 and 8 respectively. Let's go ahead and solve inside the parentheses. 4 plus 8 is 12. And now we have some options. We can say 6 times 12 is 72, and 1/2 of 72 means 72 divided by 2. Or I can also say 1/2 of 6, which is 3, and multiply 3 times 12. I'm going to choose this option since those are smaller numbers that I can deal with. 36 square units is my area. To find my perimeter, I have to just add the sides, which are 4 plus 7 plus 8 plus 7, not including the number 6. 7 plus 7 is 14 plus 4, 18 plus 8, 26 units. The diameter of a circle cuts the circle in half along the center point, and the radius is half of that diameter. It goes to the center point exactly. So I like to say that I listen to the radio half of the day. I listen to the radio, the radius is half of the diameter. So here we have a radius that is 5. To find the area, I use my area formula, pi r squared, where r is 5. Now 5 squared is 25, and I am going to rewrite my answer as 25 pi square units. It is really important to include the pi. Please include the pi, don't make the same mistake I did. Now the circumference is your perimeter. It means you go around. 2 pi r is our formula. 2 times pi times 5. 2 times 5 is 10, and we maintain pi. We can also multiply the pi out. Pi is 3.14. So 25 times 3.14 is 78.5 square units. Both the answers are correct. For 10 pi, I can say 10 times 3.14, which is 31.4, and that is also correct. A composite figure is made up of many different shapes. Here we have a semicircle. It is half of a circle with diameter 7. Let's find the area of the semicircle. Pi r squared becomes pi times 3.5 squared because the diameter is 2 times the radius. And 3.5 squared is 12.25. I bring down pi and notice that I have to divide by 2. That is because I only have half of my circle. This is 6.125 pi square units. In order to multiply this, I can say 6.125 times 3.14, and I am left with 19.2 square units. It is important to not leave pi here as it will help us finish the answer better when we have different types of figures. But there is another circle, or at least a part of a circle, with a radius of 3. Well, let's find our area. Area equals pi r squared again. where pi times 3 squared is the same as 9 pi, or pi times 9. We definitely want to multiply by pi, so we have an answer with decimals, and 3.14 times 9 is 28.26 square units. However, I do not have the whole circle. In fact, I only have 1/4 of the circle, so I am going to divide by 4. Break this into 4 equal pieces. 28.26 divided by 4 is 7.065 square units. You may be asking, can I just round? Yes, you can. However, it's nice to have some decimals just to get close to an exact answer. Moving on to this trapezoid, we see that the height is 3 because we have some congruent sides, and we have 2 bases. Base 1 is 7 and base 2 is 9, or the other way around. Well, let's plug in our values. Area is equal to 1/2 the height, which is 3, times the 2 bases, 7 plus 9. And 7 plus 9 is 16. Now I can think of multiplying or dividing first, and I'm going to divide because 16 divided by 2 is an easy 8, and 8 times 3 is 24. You could also multiply first and then divide at the end. Both options would be correct. You'll get 24 square units. Finally, for our rectangle, we have 3 by 9 rectangle. This rectangle has length 9 and width 3, or the other way around. It's not really important which one you label which, because 3 times 9 and 9 times 3 are both 27 square units. Now we have found all of the different parts of our composite figure. In order to find the area, we simply add all the values. 19.2 plus 7.065 plus 24 plus 27. Notice that if you add, you have to place the decimal points over the decimal points. 5, 6, 2, and 9 plus 7 plus 4 plus 7 is 27. I carry the 2. 2 plus 2 plus 1 plus 2 is 7.